Hello, and welcome to today's lesson. We're on lesson 4 in our Logical Reasoning 2 unit. Today we're going to be looking at the specific type of triangle, the isosceles triangle. And we're going to understand the relationship between the legs of an isosceles triangle and understand the relationship between the base angles of an isosceles triangle. So when we're looking at our isosceles triangle, the one thing that we'll notice, we have two equal side lengths. We call those two side lengths legs. As soon as we see the tick marks, we want to know that they're equal to each other. Okay, any numbers we have, we want to fill in from one side to the other. And then what we're also going to look at and find is the idea of the base angles being congruent to each other. So we would put tick marks in those angles, and we can fill in those pieces overall. We have the base side, which is the one side that's opposite of the two legs, and then we have the vertex angle, the one angle in the triangle that is not the same length as the other two. So when we look at an isosceles triangle, okay, we need the tick marks to show us that they're equal. As soon as we know that the two side lengths are equal, what we know is the two base angles are going to be equal. So we always want to copy over whatever is in one base angle, copy it over to the other, and then we can use our triangle conjectures, knowing that the three angles of a triangle add up to 180. The fact that we've got the two z's here, then we know that those two angles are equal to each other. So we can just do some quick math on the calculator. 180 minus 24. That tells us that there's 156 degrees left over for the last two angles. And then we divide that by 2 to find out that z is a 78-degree angle. Looking at the picture, that makes sense, because remember, we're looking at every angle and we're trying to say, is it less than 90, equal to 90, or greater than 90? Okay, and when we're solving and answering questions, we want to make sure that our answer matches what we see in the image. Okay, our next isosceles here, we've got the two equal side lengths, so we know that those base angles have to be equal to each other. So that makes x pretty easy. X is 50 because it has to match the other base length. Okay, we can put the tick marks to show that we have congruent parts there. Now y is whatever's left over. So we've got 50 plus y equals 180. Subtract 100, y equals 80. So, we have to understand sometimes it doesn't always look perfect in the image, but we should always be able to make sure that we know, bigger than 90, less than 90. We can see this upper angle here is bigger than 90 degrees. We know that these two base angles then have to be less than 90. Okay, they're asking for A, which is a side length. Okay, understanding that the tick marks show us that we have congruent side lengths, or side lengths that are the same measurement. And now to find the base angles, once again, it's whatever is left over from the 180. So 180 minus 100 equals 80. The 80 is equal to the two b's. So we divide both sides by 2, and we get b equals 40 degrees. So each of the base angles is 40 degrees. The most common mistake in this situation is forgetting to divide by 2. Okay, now, working through the converse. So we're just trying to flip around the statement and how it's worded. If the base angles of a triangle are congruent or equal to each other, then the triangle is isosceles. So we could test. We might not know that it's an isosceles triangle. But when we look at the picture, as soon as we know that the two base angles are equal to each other, then the side lengths across from those angles have to be equal to each other. So that means that x is a side length measurement, would equal 10 centimeters, and y is the leftover amount from our 180. So we have 271s plus y equals 180. We have 142 plus y equals 180. And then we subtract 142 from both sides, and we get 38 degrees for that upper angle. Okay, makes sense. It's a less than 90-degree angle. We're always trying to test and make sure that when we're looking at angles, looking at answers, that they tend to match up for us. Okay, last little bit of review here for a couple examples. Okay, remember our exterior angle theorem. We've got a 145 on the outside. We have an isosceles triangle based on tick marks on the sides, congruent side lengths. So now I can fill in. So I know that A plus A equals 145. Okay, now remember that exterior angle postulate, if you're not comfortable with that, if that's not something that you really want to use, we can always use the three angles of the triangle by dealing with the linear pair as well. So we've got 145 divided by 2, and we have 72.5 for each of our base angle measures. Okay, now working with side lengths is another thing that we can do. Okay, so we can work with the side lengths of the triangle. Always remember, any information you're given, if you can copy it to another spot, we want to do that, because we're going to try to find this measurement here for AC. And what we know is, since the two side lengths are equal, the two angles across from them are equal. So C and A are going to be the same measurement. Okay, we have our perimeter of 25 centimeters. Remember, perimeter is the distance all the way around a shape. So for our perimeter, we've got 9 plus 9 plus x equals 25, or 18 plus x equals 25. We subtract 18 from both sides, and we get x equals 7 centimeters. And then finishing up, looking at our angle measure for C. Okay, A and C are equal to each other, so 2 of angle C plus 38 equals 180. Okay, and we just have a very constant process that we do here. Okay, we're going to subtract the 38 from both sides. So you can see how much algebraic work is also involved here. Divide by 2, and we saw this angle measure earlier, 71 degrees. To finish up what's left. Okay, that concludes our lesson looking at the isosceles triangle. Thank you and have a good day.